My name is Andrew Ondrasiak, and I have a passion for numbers and the meaning behind them. Throughout my entire life, I have always been interested in business and finance. I got into biotech investing because my parents own a pharmacy and I got introduced into the pharmaceutical world. Biotech stocks in particular are notorious for having major jumps and crashes throughout their history if they go public. This is because the companies have drugs going through the FDA pipeline, and at phases 1 through 4, the drug could get rejected. This would result in the company's valuation going down if the new drug was projected to be more cost-effective and would therefore get a larger market share in whatever ailment it was curing. On the other hand, if the proposed drug gets passed through phases 1 through 4 and gets granted approval by the FDA, this would send the company's valuation soaring, as they would have gotten a larger market share, and that would mean more money, and that would equal more dividend payings for the investors. So I knew my portfolio should contain something I could fall back on if I held shares in a company whose drug got rejected by the FDA. As of now, my portfolio consists of biotech giants AbbVie and Celgene, just to name a few. My safety is the Dow Jones Industrial. The Dow Jones is a great investment long term. For the past 40 years, it has yielded an average annual return of 8%. In addition, the Dow Jones is a very stable investment as it is comprised of the top 30 companies in the US. The Dow Jones stocks in my portfolio are being compounded, and that means whatever money was made from one year would get reinvested to the next. But exactly how much money would that actually be? So I decided to make a function and plot that on a graph. So right here is the function I made. So the $10,000 is the money you'd start with. Of course, you can change that to $100,000, $1 million, $250,000. But for simplicity, we're going to use $10,000. And the interest rate would be 8%, so you do 1.08 multiplied by 100,000. And you'd have it to the nth power to make sure it goes on forever, and that's why the exponent is there. But if we had it going forever, it would literally just look like a straight line if we zoomed out far enough. So that's why we have this right here. So 0 is the starting gear, 0 years, and then 40 is the ending gear. Now 40 years is a long time to have your money in an account. So the average time would probably be about 30 years. But the great thing about Desmos is that we can plot where that would be. So for 30 years at an 8% interest rate, we would have $100,000. But the thing is, there's inflation, and inflation would decrease your profits. So inflation would decrease the average interest rate to 6%. And so that's why we have the line in the red, the red function. So at a 6% interest rate over 30 years, we would have $57,000. Now that's still a great amount of money, but what if we did absolutely nothing with that money? What if we stashed it under our bed? So if you stashed it under your bed, the inflation rate of 2% would dig into it. But what if you put it into a savings account? So the average savings account interest in the US is 0.05%. And with the inflation rate of 2%, that is a very small figure. So to simplify things, we're not really going to do anything. So if you put all your money into, say, Wells Fargo at a 1.01 to 0.05% interest rate, and that's percent, so it's not it's not this, it's a 0.00. It'd be that. Yeah, basically nothing happens. So if you do that at the end of 30 years, you would have $54,000. Your purchasing power has almost nearly been halved. So the great idea would be invest it into the Dow Jones. And that's the beauty of compounding interest right there.